Hey, honor student. Day 29 video coming your way about impulse, momentum, and systems. Hope your notebook's open and ready to rock and roll. Topic 5, linear momentum. As we said, the major idea, linear momentum in a system is conserved. The amount of straight line motion between objects is the same before and after they interact in an isolated system. So be very careful. We got to define what a system in isolation is one last time. System is two or more objects interacting. An isolated system means there's nothing outside the system interacting with it. So if there's something from the outside having a force on the objects, it ain't isolated. If that force is unbalanced, it ain't isolated. So for example, is this an isolated system? Two cars collide in a gravel roadway in which frictional forces are there and large. And the answer is no. And here's why. The friction is an external force. It causes both objects to lose their momentum, their motion. So it takes away motion from the system. Where does that motion go that the friction takes away? To the earth. So if we say both cars together are the system, then this is not isolated because some motion leaves the system to the earth. If you instead say, however, that the system are both cars and earth, then yes, it is an isolated system because the earth is part of that and it absorbs from the motion. So question, over the last 200 years, is Earth an isolated system? The answer, nope. As you said in class, meteorites and things that hit have been adding, subtracting from the motion. Plus, any rocket that leaves Earth and never comes back has taken some of Earth's motion and make it move. Therefore, Earth is permanently changed because of it. So Earth itself has things externally hitting it or leaving it. That means it's no longer isolated. So you're on a skateboard that can roll without friction. Yeah, right. A friend tosses a bowling ball to you. Is it an isolated system? Here's the picture I kind of want you to think about. System. There's you and the board, and the ball's being thrown in. Therefore, it's not isolated. The momentum of the system is not conserved. But the momentum of the ball, you, and the board is. So, since the motion of the ball is from outside the system will either gain or lose overall motion. So the ball moving plus the still you and the board combined equal all y'all moving. So this external force changed your system from not moving to moving. So now you take the ball and throw it back to them. Is it an isolated system? Kind of, yeah, it is. Because it starts off with you, ball, and the board, and the ball goes away, but the ball motion comes from you. The ball goes forward, you go backward. Therefore, the system still works. Because the still ball plus still you plus board equals the ball forward, you backwards. That is an isolated system. So the whole point is that systems can be like defined by you, just like we define positive and negative for imbalances. But these system pictures are important to help identify what's going on both for yourself and others. So here are the definitions. I'm going to ask you to pause while you write all this down, and we'll come back to it. And you're back. So we have the idea, momentum is P. It's the motion which involves both mass and velocity. In equations, momentum P equals mass times velocity. Its units are kilogram meters per second or Newton seconds. And in an isolated system, when two or more things interact, momentum is conserved. And then we have impulse. Impulse symbol is delta P or I, usually delta P. And the change of momentum of a single object is called impulse. So if you speed up from something, you got an impulse. You changed your motion. And there are two equations we're going to show. The first one involves the change of momentum. Since momentum is mv, it's your final momentum minus your initial momentum. Or the other equation is change of momentum is also average force. Impulse has the same units as momentum, since impulse is the change in momentum. And when there's a change in motion, there has to be a force. So we use it to figure out the force during a collision. So we have momentum and impulse. Those are our major ideas for this topic. So for example, I drop a bear and a ball. They have equal mass and they hit the ground. The bear hits and comes to rest. The ball hits and rebounds up. Here's a picture. Bear hits, ball hits and bounces. This is a non-isolated system because the bear is being pulled by something outside of it, and that is the earth. The bear loses its momentum to the earth. So the bear slows down, the earth speeds up. Both have an impulse because they both change their momentum, but the ball has more. Think about it this way. The bear went from fast to 0. The ball went from fast to 0 and then went to a fast opposite way. That's more of a change than just simply fast to 0. So the ball had more impulse. We don't know which had more force from that same impulse because we don't know how long each one took to hit. If you imagine, if the ball took a really quick time, then it has a large amount of force. If the bear had a quick time, it also had a large amount of force. So we have to know the time to know about the forces. And with that, I look forward to seeing you in class.